And now here in section 5, all right, we're going to be introduced to the volume formulas for both pyramids and cones. We already worked with prisms and cubes and cylinders. Now we're going to do the same for a pyramid and cone. So remember that a pyramid, okay, I'm just going to do a square base for this pyramid example. Okay, it's one base, 1 point, connect all the vertices. Okay, the volume formula for this is B, area of the base, times the height, divided by 3, or multiplied by 1/3. Okay, so it's the same idea as the prism, except you're going to divide your answer by 3, okay, or multiply by 1/3. And for a cone, same idea as the cylinder one, okay. Remember that the area of the base is pi r squared, so we've got 1/3 pi r squared h. Okay, so we don't have to worry about slant height, luckily for these. That's only for surface area. This one is just going to be the height of the whole thing and the radius. Okay, so we've got, this is an example of a cone, it's just upside down. We've got the radius and the height. Okay, let's just dive right into examples. So, this first one's a little bit difficult because I'm going to give you a hexagonal pyramid. Okay, so that means that the base, oops, I gotta probably turn the pen on. So the base is a hexagon. Okay, it looks like that. We've got something like that. Okay, pyramid-ish. Base edge is 2, and the height of the whole thing is 5. Okay, so what we have to do is we need to find the volume. So V equals 1/3 BH. In order to find the area of that base, we've got to draw this hexagon and solve it. Okay, so we've got the base edge here is 2, so we'll draw the apothem like that. Okay, well, we know that this is a hexagon, so it's always 30, 60, 90 triangle. Okay, it's this bottom side here is going to be half of 2, halfway of the side length, so that's 1. And so the apothem is going to be root 3 times bigger than that, so 1 root 3 or just root 3. So the area of that base is going to be 1/2 the apothem, root 3, the number of sides, 6, side length, 2, and the height is 5. Okay, so that's everything we need. All right, we're going to multiply the 1/3 times the 1/2 times the 6 times 3, or sorry, times 2 times 5. We're going to leave off the root 3, do all that together, and you're going to get 10. And so the volume is 10 root 3. Just throw the root 3 on the end. Cubic centimeters. Okay? And number 2, I give you the radius, I give you the height, you got to find the volume. Well, the volume of this is 1/3 pi r squared h. So we'll plug in the radius, plug in the height. It's basically 1/3 pi 6.7 squared times 10.2. Okay, so we'll do that. We have 1/3 times 6.7 squared times 10.2. Don't worry about the pi, throw that on the end. So we have volume is 152.626 pi cubic meters. And number 3, very, very similar to this, except I give you the diameter. We don't want the diameter, we want the radius. We need to divide that by 2, so it's 3.1 feet. I've already given you the height, now you've got the radius, so you can just plug it in. Pi, let's just go right to the 3.1 squared times 7 divided by 3, right? Or 1/3 times all that stuff. I'm just showing you 2 different ways you could do it. Okay, so we could just do 3.1 squared times 7 divided by 3. Leave the pi off for now. Convert it to a fraction. It's really big, so let's just round. We've got volume is 24, or 22. That's not right. 22.423 pi cubic feet. Okay. Number 4, right, and number 5, we're going to work backwards just like we did in the last one. Alright, number 4, I give you the volume of a cone. Let's draw the cone. Okay, I give you the volume of it. I give you the height right there. I want the radius. Okay, so we have volume equals 1/3 pi r squared h. We're going to plug in our 2262 for volume. I don't know why that says, I don't know what that a is doing there. Should be just cubic feet. So we have 2262 equals 1/3 pi r squared, and 15 is h. So we take that 2262, divide by 15, multiply by 3 or divide by 1/3, and divide by pi. And we'll have r squared equals 144, so r equals 12 feet. Okay, that's the radius. And finally, number 5. Number 5 is pretty tough. Okay, so we've got a regular triangular pyramid, so we've got an equilateral triangle down here that creates a pyramid. Okay, kind of like that. Remember, all the base edges are the same. So we got the base edges are 2√3, and the volume of the whole thing is 5√3. So we need to find the height. So remember that the formula for this is 1/2 or 1/3 base times height. All right, we have the base, we have the volume. We need to find. Oh, sorry, we need to find the area of the base with our base edge, and we already have the volume, so then we can find the height. Okay? So if we just draw this equilateral triangle, base edge is 2√3. Remember, beginning of chapter 11, if you look at chapter 11, if you look at your theorem sheet, you have the area of an equilateral triangle is s squared, or 2√3 squared times √3 divided by 4. Okay, so we have to do 2√3 in the calculator. Type in 2√3, make sure you close the parentheses around the whole thing. Square it, and you should get 12. So this is equal to 12√3 over 4, which could reduce to 3√3. Okay, so our area of our base, sorry, I don't really need the a there. The equation for that, variable for that, is capital B. Okay, so the volume is 5√3. The area of my base is 3√3. I want to find the height. Okay, so I could take 5√3, divided by 2√3, multiply by 3 or divide by 1/2, and height is going to be 22.5 centimeters. That is it for this section.